Alright everyone, this is our last video on sine, cosine, tangent functions, so our trig functions, and we're going to do two more examples similar to what we did in the last video where we are finding the missing measures of sides as well as some angles. So if you remember last time we looked at this example 2 here and we tried to find the measures of theta, x, and y. In this case we were given 32 degrees and we were given the opposite side and we wouldn't always be given the opposite side. So we're going to look at two more examples where we could be given different information. So if we're looking at this, we have our third example 3. We're trying to find theta, x, and y still. This time we're given an angle that's 30 degrees and a side of 24. I'm going to write SOHCAHTOA up here just so we have that down and can reference it. Remember, I know I've said it a million times now, but sine, opposite hypotenuse, cosine, adjacent hypotenuse, and tangent, opposite adjacent. So those are the main trig functions. Now if we're looking here, I'm going to label my sides that are associated with this 30 degrees because that's the angle we know something about. So across the way we have our opposite, y is our hypotenuse because it's across from the 90-degree angle, and our longest side, which leaves that 24, is our adjacent. So if we're looking here and we just want to already look at this information that we have going on. We have a 30-degree angle. We're missing one angle. So actually let's just solve for theta right off the bat here. We know that the interior angle sum of a triangle is 180 degrees. They always add up to 180 degrees. So if this is 90 and this is 30, we can figure out what theta is by doing 180 minus that 90 minus that 30, and we're left with 60 degrees for theta. And then let's look at our triangle again, and we're looking for, let's just look for x here. So x here is our opposite, and we know the adjacent. So if we know, or if we don't know the opposite and we're looking for the adjacent, but we still have an O and an A, we're going to end up using tangent. So if we know tangent of 30 equals our opposite over adjacent, we're left with this, tan 30 equals x over 24. Now this one is actually a lot nicer than that second example we did. Oops, wrong paper there. In our second example, when we did tangent, we had tangent of 32 equals 17 over x because we knew our opposite and we didn't know our adjacent. But we had x in the denominator, so we had to do a two-step problem. We had to do multiply by x to get the x on the other side and get it out of the denominator. Then we had to divide by tangent of 32 to get x by itself. So we had two steps to get us out of that and get x by itself. In this case, since our x is in the numerator, all we have to do is get rid of this 24. And since x divided by 24 is what we're looking at here, to undo that division, we want to do the inverse operation of division, which is multiplication. Multiply by 24, and what we do to one side, we have to do to the other. So we know 24 times the tangent of 30 is equal to x. So then if I type in 24 tangent of 30 into my calculator, I end up with 13.9 is what x equals. So I can even put that here if I want. Now if I wanted to, I could set up Pythagorean Theorem like we talked about last time, and I could do 13.9 squared plus 24 squared equals our hypotenuse squared, and I could solve that for y. But I'm going to show you the trig version of how to solve this just because that's what we're talking about this chapter. Alright, so we're looking for y, which is our hypotenuse, and we still know 24. So if we have an adjacent and a hypotenuse that we know things about or are looking for in relation to that 30-degree angle, we want to use cosine, which our adjacent and our hypotenuse is used. So cosine of 30 we know is equal to our adjacent over our hypotenuse. Now y is back in the denominator, what we're looking for. So we're going to have to do two steps like we talked about in example 2. So let's get it out of the denominator by doing the inverse operation of multiplication. What we do to one side, we do the other. So we know y times the cosine of 30 equals 24. Y is not alone, it's being multiplied with that cosine 30. So I'm going to divide by cosine 30 to do the inverse operation there. Divide by cosine 30, so we know y is equal to 24 divided by cosine 30. So I can type that in my calculator, and when I type into my calculator, again, make sure we're in degree mode. You're going to end up with 27.7. And if we just go back, we want to kind of check our work, kind of just make sure everything looks like we've come up with accurate answers. And we have 24 as one of our sides. This guy's smaller with 13.9. This guy's the longest with 27.7. So that's really good. And if you remember back to chapter 7, we had our side angle relationships theorem, which meant that the smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. Basically, that the angles and sides have to be proportional. So if we have 30 to 13.9, 13.9 is our smallest side, 30 is our smallest angle. 60 degrees is our most middlest angle, and it's opposite the middlemost side, 24. And then our largest angle is 90 degrees across from our largest side, 27.7. So we probably ended up with the correct answer, and I guarantee you we did. So this is awesome. That's example 3. Let's look at one more example, because in this case we were able to always do 180, subtract our 90-degree angle, subtract, and basically figure out our third angle just using the fact that all triangles add up to 180 degrees. But what if we're missing 2 angles? So for this one, now we're trying to find the measures of alpha, beta, and x. Alpha and beta just stand for the 2 missing angles. So in this case, we have x, which is a third side. So if we know 2 of our legs already, we can just use Pythagorean Theorem to solve for that third side. In this case, this is a hypotenuse. So I'm going to do, this is a leg and that's a leg. So I can do 5 squared plus 12 squared equals x squared. In case you forgot Pythagorean Theorem, it's that a squared plus b squared equals c squared. So if I do this, 5 squared is 25, and 12 squared is 144. That equals our x squared, that hypotenuse. 25 plus 144 is 169. It's x squared. I want to get rid of this squared, so to do that, I do my inverse operation of square rooting. When I square root both sides, square root of 169 is 13. So x is equal to 13. Sweet. So now all we have to find is those missing angle measures. So if you remember back to, I think it was the last video that I made, our last video we talked about whenever you're missing angle measures, you can use the inverse trig functions to find those. So let's look at alpha real quick. If we're looking at alpha, let's label our triangle. We know our opposite is the one across from it, adjacent is the leg next to it, and the hypotenuse is the longest side. We know 5 and 12. 5 and 12 were given to us from the problem. 13, we are right, but we don't, what if we happen to make a mistake? Let's use just the ones we know for certain. So we know opposite and adjacent. So if I write down here, SOHCAHTOA, I know an opposite and an adjacent, so I'm going to look down here, and that has to do with tangent. So I'm going to use the tangent of alpha is equal to opposite over adjacent, so 5 over 12. Now I want to get alpha by itself. So I'm going to use the tangent inverse to get rid of tangent and leave you with alpha. And what I do to one side, I have to do to the other. So I'm left with alpha equals the tangent inverse of 5 over 12. And if I type that in my calculator, again, make sure you're in degree mode, you end up with 22.6 degrees. Same idea for beta, except beta's over here, so I'm going to relabel my triangle. And now my opposite is 12, my adjacent is 5, and my hypotenuse stays the same. Notice just the only things that flipped are the opposite and the adjacent for each of these. So I'm still going to end up using opposite and adjacent, so it's still tangent. So I have tan of beta is equal to, in this case, 12 over 5, the reciprocal of what we did the last time. So I want to get beta by itself, so I do the inverse tangent. And what we do to one side, we do to the other. Those cancel out, and we're left with beta is the inverse tangent of 12 over 5. And I can type that in my calculator and get 67.4 degrees. And if you check 67.4 plus 22.6 plus 90, it's going to give you a solid 180 degrees, so we know we're right. So if you need any more examples, please feel free to email me. And if not, good luck on your homework, and I can't wait to see how you guys do with this.